Okay. Alright guys, hope everyone's doing alright. So we are going to get started here in just a sec. So like I mentioned, I am not going to be doing like a live presentation or anything, at least with regard to the PowerPoint presentation that I have. But the PowerPoint should be uploaded to Canvas, so if any of you do want to follow along, that will be there. Um, if not, then all the PowerPoint related info will be in the session recording as well. So it's not like that information isn't going to be anywhere. It'll be on the recording if you need to go back and look at anything. The only reason I'm doing it this way is just because there is a handful of information that we're going to talk about today, and I want to make sure we can get through it not super fast, but quick enough so that we have enough time afterward to sort of go through things and kind of have a good session where we can kind of actually do some problems and kind of work through those in-class assignments a little bit. And kind of like last time, I think last time worked out pretty well where I was answering any questions with regard to the in-class assignments and kind of going through it with you guys if you needed anything. So we'll do that again today. There is two today, but there is one homework assignment that incorporates most of the topics. So if you guys do have any questions about any of that stuff, definitely make sure you let me know. Hopefully a good period of time in advance. Also, with respect to the homework assignment that's due tonight, I think I checked maybe about a half hour ago and I saw maybe about 13 or so entries, which is not the entire class, clearly. So hopefully if you guys are having any issues with that, definitely let me know. I don't want anybody getting points marked off or having the assignment come in as late just because people were confused on how to do it and didn't ask any questions. So that is due tonight. I'll be sticking around, so if anybody has any questions kind of near that like in-class assignment time, and they have any questions with regard to the homework as well, let me know and we'll be able to work through that stuff. In addition to that, I'm making it such that the in-class assignments start at around noon the day that we have our lecture, and go until the following midnight. So Friday at midnight. Just because our class is a pretty late class, and that doesn't leave a lot of wiggle room for you guys to go through whatever we were discussing that day and then end up not really knowing too much about how to do the in-class assignments. So I want to give you guys a little bit more time. So that should be ample time for anybody uh, who is not too sure the day of, to be able to kind of work on it the following day. We'll talk more about it a little bit later, Matt, when we have some more time tonight, just because I want to get through some of the lecture material. Okay, so today we are going to be talking about patterns, the fillet and chamfer options, as well as the hole wizard. So the hole wizard is kind of the big thing or the big topic of today. It has a lot of stuff in it, and I know that it can kind of be tricky at first. So I want to make sure that we don't spend not a whole lot of time on patterns. The patterns and the fillet and chamfer are useful features, but the hole wizard is going to soak up a lot of time. So let's get started. So the first thing that we're going to discuss is patterns. Um, Patterns. So in the PowerPoint, if we have some specific feature that we might want to mimic or kind of create more of, then we can use the patterns feature. And there's honestly a ton of stuff that is within the patterns menu. So first things first, let's actually just get a sketch going. And I should be streaming SolidWorks on Discord. So in fact, let me just switch over from the PowerPoint. Oop, not what I wanted. So I'm just going to create a very basic rectangle option here. I'll smart dimension it, but I'm not going to be too crazy with regard to what the dimensions actually are, since I'm more concerned about just creating some sort of a rectangular prism feature. So let's just make this 20, and then let's just put a hole through it just so that we can uh, have a feature that we can replicate. So I'm just going to create some arbitrary circle, and I am going to define at least some details about this circle just because it'll make things easier in the long run. So I'll just say that it's 15. I'll say that it's about 10 away from that side, and similarly, 10 away from the other edge as well. Okay, so we have a feature here. It's fully defined. It's all nice and dandy. Or rather, we have a sketch here, and then we can create a feature. So we have a hole uh, in our rectangular prism here that we got. What we want to do with this is we want to be able to mimic this feature either in some sort of pattern, in some manner. So in the Features tab, we have our linear pattern tool. So the linear pattern is kind of going to be more on like the center right of our Features menu. So if we click on that, and keep in mind, we already have our feature selected. We don't necessarily have to have our feature selected, but it'll help because then we won't have to designate it after the fact. So there's a lot of stuff that's already on this features menu right here. So let's kind of break things down individually. The first thing, kind of pretty similar to what we've already seen before, is some sort of a direction. This is just specifying because it is a linear pattern, it needs to follow some kind of a line. So having a linear pattern, we can designate a line or an edge, like preferably an edge considering we're already creating this feature on some other type of feature. So if I want this feature, this hole, or rather this extrude cut, to be mimicked, I guess in the X direction you could say, or kind of horizontally, well, I'll just click on any edge that's moving in that direction. So there are several, technically there's, at least 4, so I can click on any one of those. And upon clicking on that, it's already going to give a bit of a ghost image of what we might expect. And I'm going to start on the spacing and instances. So, kind of as the name implies, spacing and instances is going to designate how many instances of this feature we would like to replicate and what distance apart they are. Something to keep in mind is that there's overlap happening here. The reason for that is because we only have a distance of 10 millimeters. And another thing to keep in mind, it's from centroid to centroid, I believe. So the center of this circle and the center of the next circle that is being projected is the distance that it's given here. So if I increase this distance, it goes in increments of 10, but if I increase this distance, it's going to expand out a whole lot more. And then I can increase the number of instances, or I could decrease the number of instances. So if I hit select, well, it's going to immediately create those several features. So this is a good way to be able to take some sort of pattern that we might have and make our life a whole lot easier by just creating several instances of that pattern as opposed to creating each and every hole that's there, or even just creating one sketch that has all of those patterns. Let's say after we've already created a sketch, we said, oh crap, I need to mimic that feature some number of times. This is an easier way of creating those feature patterns or creating a pattern out of your features. So I'm going to go back there because maybe I didn't do everything that I wanted to do. And one thing to also keep in mind, it only created 1, 2, 3, 4, 5. So the original feature is counted in the number of instances that you have. So just keep that in mind. Another thing is, let's say I want to possibly create a grid. Well, I can also specify a second direction here. So if I go down to the direction 2, I just need to specify another direction, or rather another line, or edge in this case, that is, I guess you could say, not collinear with the original line that we gave. If I specify another one of the edges that's parallel to what we already used, it's not going to benefit us at all. It's not going to create a second direction at all. Perhaps it might be good if you wanted to kind of create some sort of midpoint where it might be going to both the left and the right, or up and down, or in two different directions, but usually we would want to specify the direction of some other direction than what we already gave. So when I hit this, it's going to specify that other edge. And then I can crank up the number of instances that it gives. So I can create a grid of whatever pattern I want using our linear pattern tool. And let's say I want to make sure that there is no overlap here, because if I already select this, it's going to create kind of some weird misshapen slots. So we don't necessarily want that as our pattern. We want it to be something that's more nice and uniform with how it actually looks. So our spacing in the horizontal direction is already good. So let's just bump up our spacing to 20. And that's apparently far too much for the amount of instances that we have, so we can just take a couple of the instances off. So now we have something that's much nicer. It actually fits on this geometry that we created. So this is much more appropriate if we want to create something that has multiple of a given feature actually on our geometry itself. What's also nice is that there's this other feature here called pattern seed only. So what that's effectively going to do is it's going to remove that grid aspect of what we're trying to do with whatever feature. So when I select that, it's only going to give essentially all of the patterns or all of the features pattern across one direction and all of them pattern across the other direction. It's not going to sort of assume that I want that grid pattern. So the seed is just referencing, well, we only want one specific thing here. We only want it going in the downward direction and in the horizontal direction here. We don't want to create extra geometry that, or exclude extra geometry than we need to. So if we have some sort of edge, this would be a good way of maybe creating holes along an edge of some given direction that we have. There's some other tools that we have here as well, though. So what I'm actually going to do, I lied. I'm going to go back here and I'm going to make these slightly nicer dimensions, just so I'm kind of more aware of what they are. So let's do it by 100, so 200 by 100. And I'll exit this sketch. And my pattern is still good, so I mean, this isn't changing at all. It's still in its correct location because this cylinder, this cutout cylinder, was 10 by 10 away from this corner here. But let's say I wanted these to be not only evenly spaced out, but I want it to extend all the way to the edge of this geometry here. So that's where the other selection tool comes in, up to reference. So up to a reference allows us kind of what you might expect. It allows us to pattern a geometry up to a given reference that's already on our geometry. It's a little bit easier to do if you have something like a flat surface here. So I wouldn't recommend it for things that are too crazy or too complex in their geometries, like more curved surfaces. Unless you're working on the flat part of a curved surface, say like a cylinder, you're not going to want to pattern a geometry along the body of the cylinder. You would want to try to do it along the top. So let's choose our up to reference. So there's a lot more selections that have popped up as a result. So the first selection here is going to be the reference geometry. So this could be virtually anything in terms of a vertex, an edge, or a plane or face. So the idea here is that we want to choose our endpoint. So I want these cutouts to basically go to this face or edge. I can select either, but an edge is also nice. So, or rather a face is nice. I say edge and then I mean face. So what it'll automatically do is it's automatically bringing all of or it's creating more instances that can be put in there. It's not assigning or it's not telling me how many it put there because it's already saying we put as many of these features as we can up to the reference that you selected, no more can go in here. The nice thing though is that it does give us some details about what's going on here. So it tells us that we have 10 instances and they are spaced out 20 centimeters or 20 meters apart, 20 millimeters apart, Jesus. Um, and just to verify that, what we can do is if we go to our evaluate and measure tool, we can select details about two different things, and I believe this doesn't give the axis here. These are going to be about 20 uh, 20 millimeters apart. So I believe if I click kind of more on the edge, so we have a distance of about 5. We designated these to be, I think it was 15. So makes about sense. There should be 7.5 on this side, 7.5 on this side. So they are about 20 millimeters apart from each other. I'll go more into the measure tool if you guys like a little bit later. It's just a good way of being able to make sure your measurements are correct. But let's continue talking about the patterns here. So just like what it says, they each have a spacing from centroid to centroid, or center to center, in this case, of 20 millimeters. What happens, though, if maybe I crank this up a bit more to about 40? Well, as you would probably expect, it's going to space them out further, but a lot of those ones that were already there have surpassed the edge that we had already here, which means it makes things a little bit more difficult to kind of create a nice even geometry or a nice even feature pattern that lines up with this edge over here. So what's nice is that not only can we select a feature or make a feature go up to a specific reference, but we can also designate how far from that reference it's also going to be. So, and also I guess I should kind of talk a little bit about the number of instances as well. If I increase the number of instances, it's just going to space things out automatically here. However, it will overlap at some point. And as you can see, kind of what I was getting at just a moment ago, you can see this ghost outline is right on the edge here. So that's a little bit of a problem. The first thing that we see is that, I mean, this is the kind of reason for it right here. It's measuring it from the centroid. So it's saying, well, the center is right there. I'm just going to stop halfway in that circle, in that cylinder, and it's not going to go any further. So if we increase this a little bit, I believe that does make sure that it goes right to the appropriate location. So I believe, let's say we measure it like this. So we measure it from about right there to this edge, about 17.5 millimeters. So it is about, let's see, we said that these are 15, so there's a distance right here of about 2.5, so it is about 10 millimeters from this edge to the center. So that's good. That is about what we want it to be. I believe that is what we want it to be. There is, however, another option. There is the selected reference. So just like how you can make sure that it measures up to the centroid of it, maybe there's another reference that you want to make sure it's centered by. And that would be whatever is designated by this seed reference. So this can be just kind of similar to whatever our original reference is. This is fairly similar as well. So this is just designating that we can select where. I like to think about this purple one as kind of where the geometry starts. And then this 10 is going to kind of space it from the end of that edge appropriately. So if I say select like the inside of this face, then it should keep things still a nice 10 millimeters from that edge that's there, even if I increase the number of instances that I have. Even if I did it from the centroid, it does about the same thing. But the selected reference, I like to think of the selected reference as kind of like your starting point. So if you select something that's where your feature might be beginning in a case like this, it's a good way of being able to uh, kind of select a like a starting point and then a finishing point. So your up to reference is going to be like your finishing point. And then maybe I want to do something that's kind of similar for the second direction as well. I'll specify the downward direction. I do want it to go right up to that edge. So I could select an edge as well if I want to. I want it to have a certain number of instances, and I don't want it to be a pattern seed. And let's see. So if I go right about there, then I think that looks like it's about right where it should be anyway, just because these are all nice measurements. But let's say I did want to select the reference or make sure that it went up to a specific reference. And we can just select that, and it should, I like a face better if I choose a face there instead. I think it should work a bit better. I think this was 10 last time anyway, so that means that it would essentially go up to the centroid of that, but it seems to be working nice now, so it should be fine then if I just select that as 0, and then do selected reference, and then take one of the patterns away. Face or edge. Oh, I see what happened. There we go. Oh, that should work. Oh, that's not entirely what I wanted it to be. I think that's why. So now if I do, so selected reference, I got rid of it. I want to make sure that that's a grid pattern. So I think it was, oh, now it's lining up with the centroid of it. So I believe if I just do 10 millimeters now, there it lines up more appropriately. And I could wedge more in there if I want to. So now I have a much nicer kind of grid pattern, almost like a, what is it? Kind of like Connect 4, almost, only much fatter here. So that's a bit of detail about just the linear pattern function. What I do want to get into next is we can also, there's more than just the linear pattern function as well. So let's say I don't necessarily want this pattern. I'm just going to suppress it. So I didn't get rid of it. I just made it go away for the time being. I'm going to create maybe a slightly different circle in a case like this. So there's other types of patterns that we have, and the next one is going to be a circular pattern in this case. So the circular pattern is going to be more along the lines of something that we might have an axis of revolution. So very similar to what we needed for the revolve and revolve cut function. For a circular pattern, we're going to need some form of an axis of revolution. So the first thing that I want to do is I want to create an axis. I didn't go into this too much before when we were talking about datum planes, but I'll kind of do a quick overview right now. If we're trying to create an axis, and in this case I want to create one that's just centered about the origin, that's going to kind of go, if I get out of that, right through this face. So it'll basically pierce perpendicular to this face of the geometry as it stands right now. So the first thing that I'm going to do is I'll select axis, and then I can go in my drop down and I can select which of the planes that I want it to be based upon. So since I already created this geometry from the origin as it starts, I can just kind of create my axis from that. So I tend to rely on what the kind of ghost image looks like. I want it to go through this, so I want one axis to go horizontally and vertically. So that's going to be my front plane and my right plane since I sketched on the top plane. So we can see here that it's already going, or the yellow marker here, our axis is going kind of directly through exactly what we want. So we'll hit select. And now we have an axis for our geometry. So let's sketch up maybe some other kind of geometry that we might want to do. And I'll just make a basic circle pretty similar to the previous example. So I'm just going to smart dimension this one more time. Let's say it's 10, a little bit smaller than the previous one. And just to make sure we have some of our bases covered, I'm going to say that it is, come on, there it is, U to U. I'll just say that it's 20 units away in a case like this. And just to further define it, it's right in the center, so it's 50 millimeters away there. I want to create some kind of a circular pattern using this specific feature. So what I'm going to do is I will click on the drop-down menu for linear pattern, and the first thing that we should see is going to be the circular pattern. So just like the revolve tool, we are going to need some form of axis of revolution in order to do this. So it already knows what feature we want to pattern. It has it selected in this drop-down, and for this axis, I'm going to select our axis 1, and I'm going to put it on instant spacing. So very similar to the linear pattern stuff that we had before, with instant pattern, or with the instant spacing, we're given, rather instead of a measurement, or rather a distance apart, we're given a degree, or rather an angle. So this angle is going to tell us how far apart it is, basically from, or rather the angle it makes from one of our features to the next. So think about it just in sense of like geometry. We have the center of one circle here. The vertex of that angle is going to be right at the axis 1, and the following point is going to be pointed towards the next next instance that we have there. And then we have some amount of instances that we are going to select. So I personally don't like this option as much, but it could be useful if we perhaps only wanted maybe it on a quarter circle or a half circle. So maybe we want this to just be 90 degrees. So we have this stretching 90 degrees apart. So it makes sense. This is 90 and 90. So basically they're on opposite ends of each other in a situation like this. And if I add another one, it'll kind of be a nice pair that we have here. And we can, of course, add more. It's just going to start overlapping then. So we'll get some kind of interesting shapes out of it. But I don't think that's necessarily what we would generally want. The next option is going to be your instance spacing, and this is, or your equal spacing, excuse me. This is going to be more along the lines of what you expect. So what's nice here is that it's already going to say, hey, how many instances of this object do you have? That's the only thing that you need to designate. It's going to divide that, divide 360 by however many you have, and it will space the features accordingly. So I like this one a whole lot more because usually just means that you don't have to do as much work otherwise. Just means that you can really just look at something and say, okay, well, how many holes do I have? How far away is it from our axis of revolution? Select equal spacing, and then it already does it automatically. So if I select this, it's going to be already some nice circular shapes kind of in almost like a circular pattern as it stands already. Alrighty. And then the next feature is going to be, I wouldn't say similar, but it's within the same drop-down menu. So within the linear patterns menu, we also have the mirror function. And as you might expect, we can take either features, or, I mean, generally speaking, it's going to be features in this case, and be able to mirror it over some sort of face or a plane. So let's say I wanted to mirror what I already have here, whatever kind of shape this is, or geometry this is in this case. So I'm going to make sure I'm not selecting anything I'll hit my drop-down menu, and I'm going to click on Mirror. So first thing that it's asking for, and a lot of these options here are fairly self-explanatory, the mirror or plane that we want to mirror this feature over. So it doesn't just have to be a face that's already on the geometry. If I had a datum plane out here on the far right, or if I had something up top, I guess you could say, it could mirror it over that plane as well. Um, it One thing that you just need to be careful of is you need to make sure that you at least have some specified distance between your geometry and that plane that you're mirroring. If you don't have that information, or if you don't designate that information, you might not get the results that you want. So let's just select one of the faces that are already here. I'm just going to click on this top face. So it knows the top face is what I want to mirror. I am now going to just select some of our features that we already have. So features to mirror. One thing to keep in mind is that if I simply select on just this, I believe it's not going to mirror everything that's on it as well. Okay, so I was correct. The reason for that is because even though it shows the outline of those features, I only selected the boss extrude. Keep in mind, the boss extrude was the only thing, or rather, it was the base of this geometry. It didn't have anything that was already cut out of it. If I had created these shapes on the original sketch and then extruded it, which means I wouldn't have a circular pattern or a cut extrude, then I wouldn't even need to worry about this. It would already take it into account. However, since I only selected the boss extrude, which only had just the original rectangle on it, it's only going to extrude that. So you technically do have a lot of power with regard to what you do want to mirror for a tool like this. You just have to be a little bit savvy with regard to if there are specific things that you do want to mirror and maybe other things that you don't. Now, if I select on the cut extrude, it'll add that. You can see that it's selected there in the blue. And then perhaps I also want to mirror the circular pattern. I believe this is also going to take the original one, but I'm not entirely sure. Yeah, it does. So kind of like what we were talking about before, the uh, the original feature is also considered an instance as well. So because of that, even though I didn't select the original extrude or extrude cut, it accounted for it in our mirror. If I wanted to, though, I could select it as well. It wouldn't hurt anything in doing so. And then, heck, even if I wanted to mirror this mirror, I could do that as well. So if I select that, it already created a face that extended double what it was before, and then I can just select all the designated things, all the things that were already here, and I'm fairly sure. Oh, and even if that's the important part as well, the mirror is considered a feature as well, so I need to select that along with the rest of the features. So when I hit OK, could not find face or plane. Uh-oh. Maybe I can mirror here. You might have to do things one at a time. It might act a little bit finicky if you're trying to mirror several things, get that aggressive with your mirroring. But if I do, I could possibly just select that. Might. Oh, come on. I think it's trying to mirror too much there. I know you can create a larger pattern like this, but I think this is proof enough that you can mirror twice, and you can kind of use this several times kind of stacked on top of one another. All right, so I already have this kind of crazy looking geometry. Let's move on a little bit more to some of the other features that we're going to talk about. So that's by and large what I wanted to go through with regard to all of the pattern tools. And I know I went a little bit quick with that, but we'll kind of use more of that tool once we're starting to get into, once we start getting into the, the in-class assignments. So now let's move on to the fillet and chamfers. So fillets are just going to be a way that we can round edges on our geometry. So what's nice is that occasionally we might want to add those rounded edges on our original sketch, but maybe later on we're just saying, darn it, I should have added that to the original sketch. I need to make sure that either along this edge or even along this curved edge, I have some sort of a fillet, some sort of radius of curvature along it, just so that it's less prone to possible stress risers. Those are a big thing when it comes to kind of simulating your models. Oftentimes, if you have parts that you're working with, edges are kind of the enemy, unless they're absolutely necessary to have. We like rounded edges because they're less susceptible to stress, or they're able to distribute stress more evenly among the geometry and not be a very focal point on our geometry itself. So let's see. So this option is just directly to the left of our linear pattern tool. So let's just hit fillet. So a couple things to keep in mind. It already sets us up on the fillet expert. I would recommend just staying on the fillet expert. It's very good at being able to determine by and large what you specifically want to fillet. I wouldn't try out the manual, at least unless you really know what you're doing. There's a lot of different options here, so it could be very beneficial, but it's generally speaking not going to be what we need to be using as often, unless you kind of want to play with it more so on your own time, and then get a better feel on how the fillet kind of interface works. I mean, stuff like this where we have like variable size fillets, I'm likely not going to throw stuff like that at you, and if I do, I would say so. I don't even know how to label some of that stuff in the e-drawings, so don't worry about that. But in terms of how we choose our geometry to fillet, the two things that we generally will look at are going to be either faces or edges. Edges give you a bit more control over what you're going to fillet. Faces are kind of just a very broad fillet, and you'll see what I mean here in just a second. So if and the first thing that I'm going to do is let's change this radius of curvature to like 1.5. So that's just going to be the radius of whatever that fillet will be. And then I'm going to click on this face here. So now there's a lot of stuff popping up. So you can see that all of these yellow edges here are the regions where where the fillet expert is going to designate those fillets to be. So we do want to be careful sometimes because we might have weird overlaps like this. So that would be an instance where we might want to be a little bit more cautious, or we might want to say
Hacking hack.
maybe somebody have their mic on. Someone can mute their mic. Um, Locations where there might be weird geometry that we're dealing with. So if we click on this, we'll kind of see the results, and it'll still make do with what we have here. It'll accommodate, and it kind of does work reasonably well, but we just want to, maybe this isn't exactly what we want it to have. Might be a little bit different than what we were trying to get out of a geometry like this. So I'm going to go back and edit, and I'm going to just delete that face, or rather I'm just going to delete this fillet in general, just so that I can start over one more time. So instead, let's say I just wanted there to be a fillet around this top face here, but I didn't want it to encompass any of these circles or any of these cylindrical cutouts here. Just by clicking all of those individual edges will allow me to be much more precise about how I fillet this geometry. So as you see here, if I hit enter or OK, we don't have that issue anymore. It's not overlapping there. And yeah, I could have just reduced the fillet size if I wanted to, but it gives me a lot more control as to how I can fillet certain shapes or fillet certain geometries. Um, it also works in nice ways. Not what I wanted. It also works in nice ways if I perhaps just click another face that's much simpler. So let's say I wanted all these guys to be much more rounded, kind of on where they intersect with each other. So I can click all of those beforehand and then select fillet, and then it should already take those things into account. It's a little bit hard to see, but it is accounting for it. And if I increase this, if I bump it up, not that much, bump it up to maybe like, maybe not 5, maybe like 2.5, and then hit OK, we'll see it a little bit more clearly. And honestly, that's another option right there. So technically, it's also considering edges that are not only, or rather, it's accounting for all the edges that are touching that face. So that's why it might be preferable to use something like that as opposed to on maybe a face like this. So it really all depends on what sort of face you're actually working with or using. Um, I kind of want to delete that one. In fact, I want to delete both of these. So, and let's see. And I can do the same thing with any of these holes here as well. So if I click on fillet, I think I can do this. Oh, nope, that's not what I wanted. If I hit fillet, and then I would need to select the individual edges here, but I would be able to do that. If I clicked on the faces, it would do it on both the top and the bottom. So think of clicking on faces for your fillets to fillet both edges, or rather any edges that are associated with that face. If you are just selecting an edge itself, it's only going to fillet that. So here, it looks entirely the same on one side, but on the other side, we can tell only half of those faces had fillets associated with them. So, and if I wanted to, I could have done this beforehand and then mirrored. So this feature would have been applied as well to these other kind of circular cylinder cutouts. All right. So, just like in the linear pattern menu, we had lots of options. There's not a whole lot of options for the fillet menu, but there is the other option that we're going to be talking about, which is the chamfer option. So think of this as just a way to cut off any edges for the benefit of just having sloped surfaces instead. So if I wanted to, I think it could do it for this entire face, but I'd rather not. Um, for the chamfer, you're typically going to want to select very specific edges that have this feature. So the one thing to keep in mind is that there are lots of other features that can already be selected right off the bat. The typical ones that we are going to be using most often are going to be the angle distance one, the distance one, and the vertex one. I mean, honestly, I haven't even really used the vertex one that much, but it might come in handy from time to time. So, as you might expect, the angle distance chamfer is just going to take some edge, designate some distance that edge should be from, or rather, the new edges that it would create be from the original edge that you selected, and whatever angle it is from the, basically whatever angle it is from like the horizontal or from one of those edges here. So if I crank up the angle, you can see that it's going to get less steep there. And heck, if I want to, I could select another edge. Then let's hit OK. So you can see we kind of created, not like terribly so, but more of like a pyramid type side shape to our object here. Something more akin to a nice sloped, I don't want to say curve, but just face as opposed to the sharp edge that we had here. So this is another good way that you can reduce stress risers. Fillets are going to be better to use. However, this is another option that we have. Say we wanted to perhaps maybe use some of the other features that we have or other options, chamfer options. If I perhaps select this vertex here, I probably have to select that first. And then it kind of auto aligns, and then now we can designate all the different distances that we have. So we can set it to be equal distance, so we would only need to adjust one number, or perhaps it might be more variable. Maybe that's a bit more extended out, and this is extended downward, or maybe let's just say that that's like 15, and this is actually smaller. This is, say, like 5. So it's a good way of getting very specific sloped surfaces on a given vertex. And then, as you might expect, the other chamfer option, the distance one, is going to be pretty similar. It's just going to designate how far it is in both directions from that original edge. So it defaults to symmetric, but typically you would probably be using the asymmetric if you were using a distance. So maybe it's 20 away from that edge, but it's perhaps 3 away from that edge there. So this is another good way of getting ones where we might not have being much more specific than the angle distance one. I can tell you right now that the angle distance chamfer is going to be more frequently used than the other two options that we have. So before we get into much more here, does anybody have any questions about some of the stuff that we have already done? I know I probably said this before, we kind of went a little bit quick through this, but going through the whole wizard is going to take a little bit of time, and I don't want to skimp out on too much time for that. So if anybody has any questions, just speak now. Alrighty. So I'm just going to create another geometry here, or another just very simple geometry, because this is, I don't want to deal with all the other crap that was on that one. So I'm just going to specify units here. Smart dimension this guy. Say this is 50. Something a bit, let's do 100. Alright, so we covered. So we covered that. Okay, so the first thing that I want to talk a little bit about is fasteners in general. And actually, before I do that, I'm going to post this real quick in, I don't think I posted this on Canvas. I'm going to post it in the Discord right now, so you guys can download it and open it up and check it out. Like I said, I want to talk a little bit about fasteners. So everybody can open that up, and then we can kind of discuss a bit about this topic. So what's nice about the hole wizard is that it's a way of creating very detailed screw holes for your geometry. So if you need or you know very specific units regarding your, whatever hole you need to create for your geometry, using the hole wizard is a great way of doing it. It has ways of adding, I believe it has ways of adding threading as well. It has much more detail, and it has an entire library that discusses a lot of details about different screw types. The one thing that you need to make sure of is you need to make sure that you know kind of what sort of screw you're dealing with to be able to accommodate said screw. And depending on the complexity of the screw, you might need to know a lot of information about the screw itself to be able to create that hole. For our intents and purposes, we're not going to get in too crazy with regard to a lot of the specifics that the hole wizard can do, but general types of screws, measurements, how large the screws might be, screw depth, all of those things are going to be things that we're going to go through. So before we get more into the SolidWorks portion of this, any sort of demo of this, I'm just going to go through the PowerPoint, which does talk about that fasteners document that I just put up. And I'll kind of explain some of those things. In fact, I might just stream it if you guys want. I'm just going to switch the stream over to that. Change. There we go. Okay. So fasteners in a general sense, these are just a way of being able to, I guess in the most basic sense, kind of lock down whatever your geometry is. So general idea here is that we want to make sure that parts of our geometry are against each other. So there's all sorts of different names that we need, or kind of nomenclature that we need to know about. So a bolt is going to be paired up with a nut as well. So and these sorts of designations, whether it's a bolt or a screw or a tap, any of these things will be added to the what is it? They'll be added to the documents just so you know what sort of fastener you're dealing with. Screws, generally speaking, will not have an associated nut with it to kind of cinch it down, but they occasionally could. Nuts are just going to be a way to kind of hold whatever your geometry is together on the other end. And then washers are just a way to kind of create more contact surface between or to your fastener, so you can kind of prevent any sort of breakage or any sort of failure in the material itself. So a lot of these details are going to come up when we're talking about the hole wizard as well. So we have hex bolts, which are kind of designated based upon the head of this bolt here. You can see that it doesn't have any sort of screw designation in there, so we would typically use, say, like a wrench, and it's going to be cinched down or fastened or held on with a nut at the end of it. Studs are essentially just a rod with a threaded end to it. Cap screws, these also have kind of that hexagonal shape to them, except they're typically not used with a nut, or you generally don't have to. Socket wrenches, specifically we'll need an Allen wrench for it. Machine screws, so these are the ones that we are typically more familiar with. So ones like Phillips screws or your flatheads, slotted. Wood screws, I don't think there's really too much with regard to wood screws that I can think of in the hole wizard, but I could be entirely wrong. And also set screws. And then, so here, there's a lot of information on this page here dealing with how a lot of these details are calculated, or not even so much calculated, but just more specifics about them. This is kind of what I was talking about when I said these are not really details that you need to be super familiar with, unless specified otherwise. So here, unless you know things about your screw, such as like your major and your minor your major and your minor diameter, so minor indicating kind of like the trough of the thread, major indicating what you would typically feel when you're holding on to it, the outermost edge. Things like the threads and the threads per inch. A lot of these details are not things that I'm not going to like quiz you on or anything like that. They might be helpful to know, but you shouldn't be screwing around with them in the in the whole wizard unless you kind of understand those details already about that screw. So that is more so when you're kind of working like in the field and like you might have someone give you the specific details about that fastener, but for our intents and purposes, it won't be entirely necessary. Um, this is more the important stuff down here. So these sorts of symbols, I got this off the internet because you can clearly see drill bite, and it's really good. So we have these other indications here. So these two right here are pretty important. This right here is indicating how deep just the head of the screw is going to be. And this is also indicating what
What the hell
kind
is a
of
drill bit?
screw you have. So mute your mic. Okay, cool. Anyway, so let's see. And then through all is just indicating that it's going through the entire geometry. So I know I mentioned that the other day. Blind is just a way to indicate kind of like what we've done before with the other, whether it be, what is it, extrusions or extrude cuts. You're designating the specific distance there. Um, And then this page here as well gives a lot of detail. So I know a lot of stuff on here might be kind of difficult to dissect at first, but we'll kind of go into it and talk about it piece by piece. So there are specific callouts that we can do on the drawing, and these are more helpful when you're dealing with kind of labeling diagrams for your geometry in like the e-drawing section. So a lot of these things, like if you create a geometry and you put it into your e-drawing, there's a whole call out feature that allows you to say, okay, I didn't just do a straight cut through this. I used the whole wizard specifically for this geometry here. From the top-down view, um, I might not know much details about it. I might just know like its basic diameter, but I can use the whole call out and it will basically list everything there. So if we're just looking at this very top one here, you can see that it's much more of like a box shape to the head it has. It's not countersunk, I believe. Yeah, it's not countersunk. Um, so this part, this very top part here is going to indicate a couple things. First of which is the diameter of the main shaft or the shank of the screw. So that's indicating that that 0.397 diameter is going straight through the entire geometry. This other indicator here, this kind of open box, is only indicating the head of the screw. So it's indicating that it has a diameter of 0.875 and it's going down 0.6 or 0.268 units. I guess in this case probably millimeters. Um, so some of the things that we need to keep in mind, this is going to be the major, or yeah, the major diameter of whatever we're dealing with, or of that specific screw, the shank of it, so the like the body of it. Similarly here, so this one here is countersunk, so it's giving us some other details here, kind of similar to on the other page. It gives this more V shape to it, and that's indicating kind of the behavior of the head. So a couple things that it's indicating here. It's saying that the drill depth, so just the shaft of the screw, has a diameter of 10.08, but it's only going down 38.1 millimeters or however much. This indicator here is telling you not only the diameter of that head, but it's also indicating the angle at which it's it's tilted at. And some of those details can be adjusted in your model. I would not play with those details unless specified otherwise. And kind of like what I said, I'll try to make sure that those details are given to you, and I'll be very explicit about telling you, hey, pay attention to the angle of the head in this case, or pay attention to this specific detail here. So for this other one, it is also giving us some more details. So it's giving us same as before, the depth of just the screw itself, but it's also giving some sort of thread details as well. So it's not only indicating the major diameter, but it's giving the threads per inch. So whenever you see like a UNC symbol, that's indicating, I can't remember what it stands for. I'd have to Google that real quick, but that's essentially telling you how many threads per inch it has. Um, this kind of arrow with a top or with a horizontal line on top of it, it's always going to indicate a depth, and the thread depth of this is going to be 0.5. So there's a lot of details kind of with this alone. Usually you won't have to play around with that too much. Sometimes this would be my recommendation. Sometimes uh, if you're dealing with geometries that might have some sort of hole that's drilled out of it, or some sort of hole that was created using the hole wizard. Um, doesn't take much to just open up that drawing or open it up as an E drawing, do the hole call out, and just see if it kind of aligns more with what is standard, or rather aligns more with what it's supposed to be. It doesn't hurt to check, especially considering we're still not really getting too much into the drawings. Okay, so let's go back to SolidWorks now. So I will switch my screen. Let's do change window. And come on. Oh, come on, Discord, cooperate. There we go. Sorry, I had to cut the stream there for a sec. Okay, should be back up though. Okay, so we left off with just a rectangle before, and let's extrude this shape. So we'll create our extrusion, and I'll make sure it's tall enough such that we can kind of practice with any of those different types of holes that we might want to create. So first things first, the hole wizard is going to be right next to where the extrude cut option is. So we're going to select the hole wizard, and then the first thing that I always try to do is I always like to designate where this is going to be. So because it doesn't really give you much details, it doesn't show you what's going on uh, when you apply any of these options. There's no ghost shape. There's nothing following my cursor right now to kind of give me an indication of what's going on. So what I want to do is I want to first designate our position. And just like previous times, we can go back in later and adjust this. Or heck, I think I can even adjust it now. So I'm going to select this top plane as where I'm working with, and it already allows me to kind of line things up nicely. It's already kind of in that sketch menu. If you look at the top left, it's already saying, hey, okay, you want to sketch on this plane, so we'll play ball. We'll figure out where you're trying to go. So I'll just select right there, and I technically can smart dimension it while I'm here. So that makes it a whole lot easier. I don't have to screw around with it later. So let's just say this is going to be 20 units and 50 units. And this is a nice way of just making sure that when I exit out of this menu, my stuff will already be fully defined upon hitting the OK button. So I'll just hit OK on that, and now it knows exactly where it's going to be. So a lot of these are specific screws, and there's a lot of details in this menu, as you can clearly see. So it might be a little bit daunting, but we'll go through things kind of piece by piece. I typically like to start off at the ANSI inch. You can do metric, but there's a lot of options in here that I honestly have no idea what half of them are. So by and large, we're typically going to be working with the ANSI inch standard. And then if we're just kind of going through all of our options, we have counter bore, so that's going to be kind of that more open box shape. We have our countersink, has that more like almost cone or conical shape at the head. We have just a straight hole, or perhaps a straight tap. We also have tapered taps, so it kind of has almost like a draft on the sides. We can create a legacy hole. I'm not entirely too sure much details about this one. I think this one just kind of allows you to play around with specific dimensions a whole lot more. Counter bore slots, countersink slots, and then just a basic slot. So these last three are going to be basic slots. These first three, or I guess you could say the first four, are typically going to be what we would interact with. And details about the specifics will also show up either on the e-drawing document. So I'll make sure to specify, hey, this is a countersink. You'll get a cross section of the image, so you'll kind of have at least a basic idea if it's of kind of being able to rule out specific ones that are actually not what you're after. So right off the bat, we can already see we have some designations here. We see how far down the head goes, that countersunk, or rather the what is it, counter bore head goes. And we can also see that it's going straight through. So it's going through all. So that's one of our end conditions. The end condition is already saying, hey, we want to go through the entire way through this geometry. And just like what you'd expect, we could do blind. We could make sure that it goes down a specific distance instead. So you can see it's going down only so far into the geometry. Let's just say we hit select on this. And then what's nice is that, technically speaking, this isn't anything that you guys couldn't do already. This is just a more streamlined way of doing it, because you can see it's already created a sketch, created some kind of a sketch on one plane, and then already this feature is kind of creating its own sort of revolve cut, only with more specific details. If I do a cross section, we're able to see those details a whole lot better. So if I kind of go back, I'll explain maybe a little bit about the end condition bit. So we can see that it went down 60 millimeters, and that's going to be, in this case, as you can see indicated here, that's from depth to tip. So that's from the very top of this all the way down to the very tip of this. So I think I made this 100, so if I bump this up to 100, it would be at the very bottom. In fact, it might not even like this, because that would be like a literal point that's cut out of the bottom. Yeah, unable to do it because there's technically a zero thickness tip right at the very bottom. So we won't do something like that. However, if we flip it to this, this is only going to be the depth up to that curve, that kind of cone at the very bottom. So now it actually goes technically directly through, and we wouldn't even have this curved surface right at the very bottom. If I hit this, it would just go straight through. So this would be no different than doing just a through all. But I don't want to do that. I want to raise it up a little bit. And I will make sure to designate on the cross-section images whether it goes down to the shoulder or whether it goes down to the tip. I'll make sure that that adds, or that is mentioned in the drawing. So let's go back up. So I kind of jumped around a little bit, but I want to just go down the list now. So in terms of the type, there's a whole bunch of options. So some of these should be familiar. Some of these should be familiar from that PDF that we were going through. So we have things such as heavy hex bolt, so we can see that it's far thicker. Maybe we want just a basic hex screw in a case like this, so it has a very small head to it, and we can make it whatever depth we want. There are socket heads, so this is kind of a little bit more standard as you would possibly see it, more kind of set out for that type of screw head. There's all sorts of different options. And no matter which one of these I pick, if I hit select, it says square head bolt in the top there. So when I give you guys assignments, homework or otherwise, I will give this information here. So whatever it says right here, that's the information that I will give you. And a lot of the other stuff you'll see as we continue will be shown as well. So just like kind of what it shows here, it shows that it's a quarter or 1/4. That's designating the size. So if I flip it to something like 5/8, now it's really fat, thick. If I hit that button, it'll change it to 5/8. So that detail is always going to be listed um, as the size of it. I wouldn't mess around with the fit of the screw too much, or the fit of the screw hole too much. This is just telling you how close the hole will be to the designated screw that you're using. So the options are going to be close, normal, or loose. As you might expect, close is just going to kind of cinch the diameter down a little bit more. It was probably a little bit hard to see at first, but if you kind of go back and forth between those options, you'll see the difference. So if I hit normal, it spreads that diameter out a little bit, and if I hit loose, it spreads it out a little bit more. That's basically just designating. So they're all about the same diameter, major diameter of the screw, but a close fit is going to mean that it's going to require more force to kind of drive that screw in, whereas normal or loose might require, well, most certainly should require less force in order to drive that screw into the appropriate hole. You can use custom sizing, but look at all the options that just showed up. There's 4 different options here, and that's going to designate the head diameter, the uh, the through hole diameter, how far down the head goes, so that counterbore depth, and also the degree, the angle of this bottom part here. So that's given from this side to this side, hence why it's something that's greater than 90 degrees. I would not recommend playing with these options too much unless something very specific comes up in one of our assignments, or or rather you know more information about that screw itself. Um, we have all sorts of different sizings as well. I mean, there's plenty more. These are just going to get far bigger, so it's going from, generally speaking, smallest to largest. And most all of these have different types. So if I go on to say, or rather, let's say I want to keep this. Let's say I want this quarter size head square bolt that is a counter bore. I'll hit OK on it, and it has that information listed. Let's say I want a different one. So I can just create another one on the same plane here. It might be a little bit easier if I get rid of the cross section, just so we're able to kind of see things a little bit better. But I'm going to choose the hole wizard again. I'm going to go to positions, select this same face. I want to line it up nicely. And then I'm going to just designate where the center is going to be, just because it'll be a whole lot easier in the long run. We won't have to designate it later and kind of pick a center. So I'm just going to say it's 25, and it's going to be stupid, but because it should recognize that it's already 50 away from the bottom, but to fully define it. So it now says that we're fully defined. So I'm going to get rid of my dimensions, and I'm going to go back to type. So now we can try out, say, countersink, countersunk screw. So we have other designations here, like a flathead screw or 100 versus a flathead screw 82, or perhaps an oval head. So these numbers here on the size are designating an angle. So you can see this angle here versus 100 degrees. It technically didn't really adjust the angle that much, but it did it by virtue of moving this moving kind of like the shoulder, or rather that meeting point, or that intersection between the head and the shaft, up a little bit more. So it did technically adjust the angle a bit further. I believe this designation does show up. So it doesn't, oh, yep, it shows it up right there. It will also show it up in e-drawing as well. So if you're kind of looking at the fasteners, remember we had talked about the countersunk ones kind of have that angle to the side of them. If you remember even more specifically, one of them had an 82, which means it wasn't using this 100, it was using this 82 degrees head, or flathead screw. Similarly, it has a bunch of different sizings, has larger ones, has smaller ones. So these numbers will also show up in whatever information I might give you with regard to the specifics about that screw, as well as the fit. That still remains the same. There's also head clearance options, so that's just kind of more details that we won't really go into too much. It's something that we can kind of play around with, but it's not going to be something that I'm going to actively create assignments around. So what I mostly want you guys to kind of be thinking about will be your hole types, the type of screw itself, the size of the screw, potentially the fit, and then the end conditions. So whether or not it goes to the entire thing or not, however deep it might be. And the information regarding whether it's depth to tip or depth to shoulder will be shown on the drawing itself. So just make sure you're paying very close attention as to whether or not I'm designating something from top to tip or from the shoulder to the tip. So just be aware of that. I don't necessarily know why that option is there, but it is. I don't think that that creates a geometry. I think the whole wizard is only specification for, what is it? Just for creating extrudes. So let's say I create that, and now pretty similar. We have something that kind of looks about the same. We also have taps. So we have, if we're going to, let's try out like the straight tap. I'm going to position it again. Just say right there, or not right there. I do want it to be in line. I see what's going on. I'll try that one more time. Position you right there. So you can see this one is not concerned about whatever the head clearance is going to be. This is just going to be a straight screw, so this would be under the assumption that the head is more so going to be like on the outside of the screw. So we can already see we're going to get some other options here as well. So just from this straight tap, we now have a couple different options as to the type. So we have a bottoming tapped hole, straight tapped hole, straight pipe tapped hole, more specifically, or just a regular one. If we do bottoming, then there's all sorts of different size specifications. Custom sizing, kind of same thing as the previous one. It doesn't give as many options because it doesn't have head clearance to it. However, we're not going to play around with that too much, and if there is any details about that, there will be some kind of a specification for it. So let's make this a little bit deeper, and then I don't know why that's yellow. I think it's because there's some conflict between this value, so the depth, and the thread depth. So that's kind of why sometimes there might be some other details that are related to these types of holes that you can make with, say, straight taps or regular holes that might be a little bit trickier to work with. So those specifications will be given. So it doesn't give really much details as to the thread, but it's just a blind thread. And then this is just showing, so tap thread depth. So that's just indicating how far down the thread will go. And you will see that that does show up uh, on the geometry itself. So I think that should work. Yes, it does. So you can see this right here. I don't necessarily know if this is, yeah, it's not actively creating kind of like a wavy geometry like you would see on the thread, but it is indicating that there is a thread there. So that is a good way to determine that, hey, maybe I don't have one of these types of screws, maybe I have something else. And it will indicate that it is a tapped hole as opposed to just a regular hole. Similarly, with just the basic hole, it'll give those sorts of details as well, or things that are similar to it. This one is not going to give any sort of thread, so really the only time that you need to worry about that is going to be with a tapped hole. But in a case like this, there's also a good handful of different types of just the basic holes. You have something like a helicoil, and then the size measurements, so these details are also indicated. So let's say we have something that's this value, so this value will show up, this number 836, it'll show up, and we have some specific depth to it. So this is just a pretty general overview. Like I said, I left out pretty much half of the ones that are in the whole wizard itself. If there are any that are there, or if there are any other types of holes that I do want to be added to the specific geometry, those sorts of things I'll indicate. Um, so that's really about all I got in terms of the lecture. I want to start getting into the in-class assignments now. Um, but before that, if anybody has any questions related to just the lecture itself, I know maybe one or two people had some questions about like the homework assignments, um, but we can talk about that after anybody might have any questions regarding the lecture itself.
Hi, Ethan. I just had a question. My computer decided to crap out on me when you were going over how to put the threading in on a
Yes.
screw. Could you go over that again?
Yeah, sure. Is my email showing up? That's stupid. Okay. So the threading is really going to only be in the case for a tapped hole. So you can see here if I mouse over this one, it's going to give details regarding just that screw alone. None of these other ones here have anything uh, pertaining to threading. So anytime you might see this kind of, click out of that, this sort of pattern to it here, that's sort of your general indicator that you have something that has a tapped hole with some kind of threading to it. So what I'm actually going to do, just to make it a little bit easier to see, I'm just going to suppress these guys, so make them go away for a second, and I'm just going to use the whole wizard one more time just so we can kind of start from scratch. So usually the tap, or a straight tap or a tapped hole, is going to be indicated by, you'd have to look a little closely, either if you're looking at SolidWorks on your side or on my side. You can kind of see a little bit of a dotted line near the top, and that's your indicator that you're dealing with a tapped screw. So I selected that. Let me just select a position first. So I'm going to place it right there. Then I'm going to go back to the type. So there's a couple different type options that we have. These straight pipe taps are typically thicker, whereas the bottoming tap and the just tapped hole are much smaller for that affiliated screw. Sizing info is about the same. I mean, it'll have different measurements, but they'll be relative to whatever information you might be given. So if I just hit this says half 14 NPSM, and then it already gives that information right there. So at half 14 NPSM tapped hole. So generally speaking, the feature itself is giving you a lot of good information right there. Um, One way, and you might have to play around with it a little bit, because even here, I chose another one, or I chose another hole type, or tap hole type, but it didn't change the name. So it didn't change it from like a straight pipe to a bottoming. So your size is going to be a very good hole specification, or it's going to be a very good way of determining um, what kind of hole type you might have, both for the general type and like the subtype. Like I mentioned, we're not going to go too much into detail into custom sizing, but I mean, you can see if I increase this degree, it's moving that up, as opposed to moving it down, kind of making it more specified. I think anything in yellow literally just means that it's not whatever the default is, I think, but you can restore that to default. Probably won't play around with that too much. And then in terms of the other indicators for the end conditions, that's going to designate both the how far down the screw goes and how far down the threading goes. Um, this information, if you kind of remember what we talked about on the fasteners PDF, I'll upload that to Canvas in a little bit. But in the meantime, um, it gives details from the whole call out as well regarding this information here. So how it's going down 47.25 millimeters from the very top to the shoulder. And it's also giving details regarding how far down the thread goes. So the thread is going most of the way down the shank of this tapped hole. If I want to decrease it a little bit, that's also going to affect or directly affect uh, the depth as well. Um, I'm guessing it's 2 times whatever the diameter is here, so there's some relations that I'm actually not entirely familiar with in terms of how this works. But I mean, if you choose through all, then you can designate specifics about how far the thread goes. So uh, it could potentially be a straight tap, but the thread might only go some distance. It might not go through the entire thing. My bad. Um, so that's one way that you can kind of get a little bit more sense as to how this hole is working for a tapped hole. Um, Up to surface, so I could designate a surface, or just I could have it go down some value. So most of this information won't be entirely changed, and it might be a little bit easier to just kind of see it in action. So I have two different tapped holes here. What I'm going to do is I'm going to make a drawing out of this, just so you guys, that must be saved, yeah. I'm going to make a drawing for this, and I'll kind of show you the whole call out option. So it should still be showing the drawing. There we go. So I'm going to pull this in, and it's already designating information about it already, which is nice to see. But instead, I'm going to do a top-down view, and from here, I actually kind of want this specific one to be a little bit smaller because it's kind of taking up too much space. And then I'm going to create a cross section just so we can kind of get an idea of both of the details. So I might flip back and forth between this and the actual uh, like SolidWorks itself, like the parts menu, but we'll go through there. So what I'm going to do first, I am going to do a section view in the view layout, and I'm going to do it right through the center of this. And then when I hit OK, I can see kind of those details about it. So it's not really showing much information about the thread, but this dotted line is indicating, and you can see it here, it says whole thread of the tapped hole. So that's already telling us kind of a very, very basic information about how far down that thread is actually going. And now if I actually start to annotate this and do like some dimensioning, there's this hole call out option. So this can be, I think it can be for very simple cuts as well, like just circular cuts, but you're primarily going to want to use it or think about it when you're dealing with hole callouts for the whole wizard. So if I click on this middle one, you can see it's giving a lot of information right off the bat. Similar for this one as well. So I'll kind of go through them one at a time. So the smaller one, it's telling us that we have, and let me actually make this quick adjustment. There we go. It should be good now. So it's telling us that we have a overall depth of 27.67 millimeters with a diameter of 9.35 millimeters. It's giving us this thread count, so the 14 threads per inch. I believe this 17 or 7/16 is also an indicator of the diameter, if I remember correctly. And this right here is indicating the depth of the thread. So, as you might expect, the thread can't be deeper than what the overall hole is. That doesn't make any sense. So if I just kind of quickly go back to our part and I click on this info here, kind of go back to the edit menu, we can see a lot of those details. It tells us the 7/16-14. That's indicating both the size of the hole as well as the threads per inch. We have how far down it goes from the shoulder down to or rather from the top to the shoulder. And we can tell that it's 22.23 millimeters deep, the thread itself. Very similar to all the information that we were given for the part. See if I click out of this and then go back. We can see a lot of those details here. Come on, update. So 27.67 and the 22.23 as well as that 7/16-14 UNC. This information here will be given just like how it's given here. So this specific detail right here that it shows, this is what I intend to add. And you can already see it on both the homework and on one of the in-class assignments. So we know that it's a 7/16, 14 threads per inch tapped hole. All that information is given here as well. And this is the information that you'll be given about that specific feature. Similarly, we have this information here. So this 1/2 NPSM, 14 threads per inch. So that information is given right here. And then this information is given specifically as the hole call out itself. So the thread depth, 41.81, and the depth of the tapped hole itself, 47.25, with a diameter of 18.97. So all those pieces of information should be given fairly explicitly. I would say that the main thing that you guys mostly need to do is kind of piece together, or at least two things. You need to make sure that the hole is in the correct spot, and you need to make sure that you're deciphering all this information that you're given in a correct manner. And like I said, this information doesn't need to be given here from like the thread depth. That's already there. So I'm not going to be telling you things like the thread depth because that information will already be there. I'll remind you of it if you need it. The piece of information that I will give is how far it is from, say, depth to shoulder, or perhaps how far it is from depth to tip. And it might be a little bit of a pain. Dimension cannot be created from the selected. Well, you're a jerk. So if that's the case, some indicator like this will be given. Because what this is telling you here is, I think it's a little bit nicer with some of the other holes that we have, like the countersink or counter bore. Those will allow you to do from depth to tip. But use this information, this cross-section information, in tandem with the hole call out. It will make sure that you get the correct measurements. Because, I mean, nothing would suck more than to have this labeled as it already is, and you choose like 50-50 shot at the incorrect uh, option. This should be a good way of deciphering which one you should pick. If this number here isn't the same as this number here, that should be a very good indicator to say this value here is not going to the tip. So I mean, just to kind of illustrate that, I should be able to, if I go back to the tapped hole itself, if I click on this, and then I say I want this depth, I want it to be 47.25 down to the tip, and then hit OK, and then I go back to this drawing. Now we see something a little bit different. This value is telling us that it goes 47.25 down to the tip. This is saying it goes from the start down to the shoulder. So that's a good way that you should be looking at that, and you should be saying this value doesn't line up with the value that it gave us. Maybe I need to pay attention to which option I'm selecting. So hopefully that makes maybe a little bit more sense. That's kind of one of the things that I wanted to hit because it's not very explicit without me adding a specific measurement here, which I do intend to do so. Anything else with regard to the lecture material? I think that covers a good bit of it, and I do want to make use of time. We still have about an hour and a half to kind of go through stuff regarding, what is it? Regarding the in-class assignments. And I mentioned this before, I don't know if any, or if everybody was here at the time, but the in-class assignments are going to open at around noon the day of lecture, and they'll be due the, what is it? It'll be due the night after, or midnight the day after. So they, generally speaking, will be always due the Friday after our lecture, unless some weird thing comes up. And that's really about all that I got. So if you guys want to open up the in-class assignments and kind of start working on those guys, and then we can kind of talk about any of that stuff. Because I know that compared to the stuff related to like the patterns and the and like mirror and chamfer and all that stuff, the whole wizard took a good period of time. So I want to make sure that you guys are not just competent with the whole wizard, but you kind of understand what's going on with all the pattern and chamfer and fillet info as well. I also wanted to go through Matt's question real quick. Having trouble with the homework assignment, I did the revolve and everything and have the part basically done. Other than that, there's a hole going through the part from the space between the drawing and the center line. Oh, cool. Awesome. Good to hear. I mean, you did it, man, so good work. I can... Let me see. I'll open up the drawing for both of the in-class assignments if you guys like. Yeah, whatever. Other than that, I want you guys to be working on them and kind of figure out what's going on with those problems, and then ask any questions just so that you feel good about some of this stuff. The first one might be a little bit tricky just because it kind of aligns up with all of the edges, or like some of the ones on the faces might align with the edges. So I hope to see kind of some questions regarding that one if you guys do have it. And one other point, I know that in the second in-class assignment, there's only one hole call out, or rather there's only one specific hole. However, it's going around a circle, or it's moving around a specific path. So something to keep in mind is that the whole wizard, just like all the other stuff that we've been talking about, is creating features. Those features can be mirrored, chamfered, uh, patterned, any of those sorts of things. So think about that. Use that to your advantage. Don't try to reinvent the wheel if you can do things in an easier manner. That's kind of my hint, I guess I could say. Um, yeah, I'll open both of these up just so you guys can kind of see it. So the first in-class assignment is this guy. It's kind of like what is it? Like a heat sink. You might have something kind of on the bottom here, and then all of these fins. I gave the total number of fins because that's a lot to count, and I know you guys can count, but I figured I would just let you know. You are going to have to make sure you know how many are going across and down as well, so just kind of be aware of those specific details there. I know it's a slightly, maybe not, I don't want to say it's simple, because that's a lot of stuff to draw. Uh, if you're trying to draw those each individually, but kind of like what we were talking about, use your patterns. Um, we went into some details about that, so use patterns for this. You'll be here all night if you try to create all 200 of them. Otherwise, let me open up the other one as well. So kind of like what I mentioned, the for any sort of holes, this information is going to be given. So just what you would see in like the features menu, all this information will be placed on the drawing itself. Good question. It is a fillet. So a good way that you can determine the difference is that uh, this has an R next to it. So that's indicating that that is the radius of curvature of it. So chamfers aren't going to have any sort of radial component to them. They're simply just a cutting off an edge, hacking off an edge of it. So it's just creating, it's technically taking at least one edge and then turning it into two. So I guess you could think of it as fillets are going to eliminate all of your radius of curvature, or fillets are going to eliminate all of your edges, and chamfers are going to add more, or at least split it in half, however many you're creating. let's create a new file. So there's a couple different ways of doing it. It's obviously a little bit harder to make things align nicely for curved surfaces. So hopefully for something that has a flat surface like this, it is a bit nicer. So let's just create something very basic. We'll smart dimension this so we know what we're working with. Let's do 200. Is it going to designate it as millimeters? Please. And 100 millimeters. And we will extrude this guy. That's plenty. And I'm just going to do something that's kind of similar. I'll create maybe something like this. I don't want that. I want a corner. So instead of adding to it, I'm just going to take chunks of it out. Pretty darn similar. I want this to be like 10 millimeters. I want these to all be even. 15, 15, extrude cut. Good. So since this is 15 by 15, it's already going to designate the center right at 7.5 every time for the feature that's given here. So I'll go into linear pattern. It's already selected, so it knows what specific thing I want to cut here. And I mean, honestly, I think I could literally select that as well as like our direction, but I don't really want to since it's part of the feature. So I'm just going to select something that is kind of more non-invasive. So I'll just select this as our edge. And it's already given, or giving some amount. Is it going to do what I think it's going to do? Okay, never mind. I was about to be very mad if it only created. Yeah, that's a graphical error, I guess. Hold on, I wonder if I could fix that. I probably can't. It's just going to bug me, but maybe I'm just... Oh, whatever. Yeah, it's going to be a pain in the ass. That's fine. I'll just do a linear pattern and ignore it. So the spacing in instances is more rudimentary because obviously it could go off plane a little bit like it's doing right there. It'll still do things appropriately, like if you're cutting things out, I guess, there's nothing to cut out here. So this isn't an issue out here on the outside of our geometry. But we do want something that the instances are a bit more equidistant. I mean, they're equidistant now, but we want something that not only aligns with this edge, but it also aligns with this edge as well. So kind of the goal here is to essentially push this over a bit more. Well, one solution is I could just say, if I'm just using instanced and spacing, but this won't fix the issue here, is that I could move this back 15 millimeters. So I believe if I just chose this to be 25, no, because that's how far they are in between each other. So it's not specific to a given reference. What we want to use is the up to reference. So I tend to like to choose a face, but you can use an edge as well. And then if we just have centroid selected, what it's doing now is it's saying that each of these should be 25 millimeters apart from each other up to this next given reference. So even this one, if I kind of figured out some of the details about it, so we said that these were 15. If I go into the evaluate and then measure, that distance right there is 10 millimeters plus the 7.5 that I would have going inward. So that's not entirely what we want. We want to make sure that it's on the edge. And what we can do is, that's not entirely going to work. I believe that's also not going to work. I always like doing this selected reference because selected reference is kind of a way to designate a very specific location that this is starting. So I might say that it's starting from like this edge, and then I want an instance number. So now I believe, well, that's just going to keep evening it out. There's an easier way of doing this if I remember correctly. So if I hit that, then it'll create something like that, but we pretty much want this edge to be aligned with that one. It requires a little bit of finesse sometimes, so I might bump that up. Now it's telling me that the spacing is 22.22 repeating. Okay. There you go. So you can use centroid as well. Um, this is just telling you whatever the offset is. So, yeah. Offset from that distance. Oh yeah, you can change the distance of that as well, or rather the direction. So all I did was I just said that I know what the centroid of this is because I know how far it is in that given direction. I know that it's 15 by 15, which means that the from the center of this box or of this square to the edge is going to be 7.5. So you kind of want to, if you're doing something based upon the centroid, you kind of want to know what half of your geometry is, or half of the distance in that direction will be. And then you can kind of add however many instances as you want. So I would say the first thing that you might want to do is kind of get this situated, understand where your reference plane is going to be, whatever the offset will be. The offset is typically going to be whatever half that, I guess you could say like the diameter will be of whatever that shape is. Um, so in that case, kind of like a radius almost. And then if you specify the centroid, then it's just going to offset it by that much. You can also use this to your advantage. So by flipping it, that means that it's saying that it's 7.5 away from this edge, beyond the edge, for 8 iterations of this. Does that kind of make a little bit of sense? I kind of explained that kind of poorly.
No, that helps a lot more.
Okay, I thought
Yeah,
my
thank you.
explanation was kind of crappy there, but okay, as long as you understand it. So yeah, if I hit select on that, then it'll kind of create more of that shape. The the pattern and up to references is a little bit tricky. It's nice to work with, or it's nice to utilize. It can just be a bit of a pain getting started with it. But if you play around with the settings a little bit more, you kind of get more of a hang of how it functions. Do you want us to keep turning in the parts, or do you want us to submit the sketches? Uh, if you guys want to play around with the sketches, I think my only concern is just that with the sketches, you guys are going to have to save both of those files and then zip it up. So you have to create like a zip file and then add it, which isn't much of a problem, but it's a little bit of an extra task. Um, I think, let me actually take a look. So I'm realizing that I'm stupid. We have like a whole lecture in like a month that's on like the engineering drawing features, or the engineering drawing sheet. I know it says pre-recorded video. Whether or not that's going to be like a video or not, or whether like I do a video or just like an actual drawing, or a video or just like a live lecture, um, I don't know quite yet. But like I would say all you guys don't even worry about the drawings quite yet. Like until after test one, I think it's more important for you guys to understand all the features and kind of like get at least a sense of what. They're not too bad, but I know that doesn't mean much coming from me since I've been playing around with SolidWorks for a while. They're not too bad, but I think it's more beneficial for you guys to understand all the features, or at least all the features generally speaking, and then we can have like a whole lecture going over like the power of the engineering sheets. Because then you'll kind of, at least some of the stuff that you do with the parts will make a bit more sense with regard to how uh, it'll kind of mesh the parts together with how you're seeing the parts, i.e. the drawings. Um, and that'll just more so come down the pipeline. So yeah, don't. I'll like make an announcement later and just say, guys, don't even worry about the engineering drawings and submitting any of that stuff until like a month from now, because we'll have a specific lecture dedicated for it. There's a lot of stuff to it, so I don't want to really get into it quite yet.
Could I ask you another question?
Sure.
Sorry, it's just easier this way
No,
than
you're good.
going to another window. So when I'm clicking into linear pattern, I'm not seeing what you had up on your screen.
Okay. So let's see. Let me go over to features again. So let me just actually go back here. So what part are you not really seeing?
So
So
I
you
don't
have.
have that little green indicator. I have direction 1. It's set at the x-axis,
Mhm.
but nothing. There's nothing underneath that gives me the option for using a reference or anything like that.
So does it just give you? Does it kind of look more like this, where you have a distance and then an instances?
Yeah, and
So
then
you
there's
have
nothing.
you have to click on the up to reference. So the up to reference will allow you to select a reference. Are you able to see that? Like click.
No,
Okay.
that's not even an option. It's
What?
yeah, that portion isn't there.
Uh,
Which is
that's
very weird.
strange. I have
Yeah.
not heard of that issue before. Let me look
Hmm.
that up. Because that's
I'm
I.
wondering if I have to turn something on. I don't know.
It should be a default. Real quick, is anybody else having that issue? Like, is anybody else not seeing the up to reference option? Because I mean, I guess technically speaking, you could math it out. It's gonna be a pain in the ass, but you could.
Yeah, I mean,
That's
I
super
did
weird
for
though.
the first one. It wasn't terribly difficult, but it did take some finagling, and I'd rather not if I don't have to.
Yeah, yeah, yeah.
Uh,
That's weird. Let me see. What what version of SolidWorks do you have? Is it 2020 or 2021?
2020.
I mean, it's 20 to 21, so it shouldn't matter.
Yeah.
But that's not like a recent feature. That's been in there.
Mm.
So I'm confused. Um,
Mm.
Honestly, what I would probably say upon first thought,
Mhm.
maybe just restart SolidWorks. Um, I mean, I'll see if I can take a look at some of these other options that are here, but that's very strange.
Okay. Yeah.
Yeah, try that first, and then we'll see. Because I don't, there shouldn't be any reason for it just to not have that option available. Huh. Yeah, I'm not seeing anything that even talks about that. Yeah, so for those of you who are working on the homework assignment, um, I would recommend uh, making a datum plane that is like parallel with like the bottom surface of the screw. And then if you do something like that, that will allow you to just kind of create that plus or cross shape either on the datum plane that's like intersecting with the screw or totally above the screw, and then you'll be able to do an extrude cut. So the idea here is that I purposefully did not add a measurement for how what like the length, like even more dimensions uh, to that screw cutout, because as long as the datum plane is in the correct place, or as long as you're extruding into the shape deep enough, it should allow you to get a correct measurement. Does that kind of make a little bit more sense, maybe? That's probably the harder part of that assignment. I mean, if you like, I can probably do a very like small demonstration. Yeah, that's a bit more for what it should be. Extend it out further though, because you can see it's kind of totally in line cut out with that plane. It doesn't have like a lip on like the edge. So you're on the right track there.
Yeah, I've restarted and redone the sketch, and it's still not coming.
What the hell?
Very
I
very annoying. But also, it like I don't know. It's not letting me repeat a cut, like pattern a cut. I have to pattern a sketch.
Are are you using, so here, are you doing it from the features tab? Because there technically is a sketch linear pattern as well, which that's
Oh.
different. So that's actually a way that you can also replicate patterns as well. I actually don't know if that has similar features, so let me check.
That's probably the issue then.
It's possible.
Yeah.
Yes, so that actually specifies a direction, but it doesn't specify a reference. Does the menu look more like this? Look more like this?
Yes.
That's why. Okay, so you actually want to be in the features tab, and there's one specific to linear patterns. It's right next to Fillet. I was actually going to recommend that feature if, or recommend that sketch feature if the features fillet wasn't or features linear pattern wasn't actually working. So that is
Okay.
another option. Yeah, sorry, I labeled it as 3A, the homework, but there's only one assignment. I can relabel it, but there's not going to be there's not going to be a 3B that shows up. I was getting ahead of myself. I was thinking, maybe I could make another one, and then I decided otherwise. I mean, even if there was one, and uh, I just didn't upload it, I mean, that's on me. It's not on you guys. So I would just say, okay, whatever. No, we're not doing that assignment. Or I would upload it and then just be like, hey, this is more practice if you guys want it. I wouldn't actually like assign it for credit.
Sorry to bother you again. In the class assignment B for today,
Yes, let me pull
um,
it up. This guy.
when I well just so when I'm looking at the specifications on the first hole screw, and it might go through for the other ones as well.
Mm-hmm.
It says that it's a diameter of 22, through all, and then the head diameter is 0.39. When I
Correct.
went into the specifications on the screw, it was like for the head diameter was like 0.390 something. So do you want us to adjust it to 0.39, or did the sketch just round the number?
It's rounding it. So I think what happens is, and I might actually be able to show you here. I'll go into a lot of this stuff later on, but you can see tolerance and precision here on the left. If I change this, like if I just say like that many digits, okay, so it's going to just adjust or just show that one. But if I do, which one is it? I think it's, oh, I see I can specify which one. Come on. That's probably more along the lines of what you might be seeing like down the line, like 0.3906. Is that kind of closer to what it shows on your end?
Yeah,
Yeah,
yeah. I
it's
just
just a
wanted to make sure,
tolerance.
whether or not we just wanted to leave it, or or if you wanted us to change it, just to get the practice for the assignment.
Nah, it's not entirely
Okay.
necessary. It's a great question though. Just because if what you can do is if I like go here and I just create a hole, um, so hole wizard. Let's say I just put a hole right here, designate the type as something simple, like one of these, do a through all. I want it to be a little bit bigger. So like something like this. If you actually look at the drop down, kind of like what I was showing before, you can mess with these designations. I wouldn't recommend it just because then you're messing with like the internals of how uh, the um,
Mm-hmm.
the whole wizard actually worked. But one thing that you can do, and I would I'm not going to be as picky about this, but I would like you guys to make sure that this is dimensioned correctly in terms of its location. So just kind of like what we've been saying, it has a minus next to it, meaning that it's underdefined. So this is the only thing that I actually need to pay attention to in terms of its dimension, and this is only showing the x and the y axis uh, on this plane. So if I go into edit sketch, then I'm able to just smart dimension it. It doesn't show me much details, but it does show me the point at which that hole starts at. So I can just say, well, it's 17 from the origin on the x-axis, and maybe it's, come on, I might just define it from like here, since it's easier. And it'd be like 35 in that case. And now we see that it's fully defined. So that's really as picky as I'm going to get in terms of like making sure that the hole that you create is in the correct place. But like I said, you can do that before or after you create the hole, so long as you're kind of being cognizant of about the location itself.
Sounds good. Thank you.
Cool. I can quickly kind of go through creating some datum planes if you'd like. I would say that out of most things, that is kind of the trickiest part because you do need to be a little bit careful about some of your references. Um, what I will say, depending on uh, where you created your geometry, so where you created the screw, that can work to your benefit. And the reason I say that is because if you created your screw like say about the origin, it makes it a whole lot easier because you're already given three free datum planes, your primary three planes, so your front, your top, and your right. So remember, you can always create new sketches on those as well. Now it becomes a little bit more difficult if you actually didn't start there. And that's why I think last lecture I kind of made a recommendation to always try to start most, if not all, of your sketches about the origin. Okay, and just let me know. I can kind of talk a little bit more about datum planes if you'd like. So we have a tapered tap here. I'm just going to select the position to be right there. And then if I just hit OK on that, then if we do just a cross section there, and let me move this cross section over a bit further. It's kind of hard to see, but this does have a very slight angle splaying upward as it, come on, cooperate. There we go. It does have a very slight angle going upward, so that's really the only difference between a tapered tap and just a straight tap. So not only that, you're also going to have a very slight notch here with most of your basic tapered taps. So unless you see kind of like this little lip where it very distinctly separates the straight portion of the tap to the threaded portion of it, then it's generally speaking just going to be a straight tap. Hopefully that answered it. That was kind of a little bit of a disjointed answer there, but um, I mean, I guess to answer your question, yeah, it will be a straight tap for that in-class assignment. If it is tapered, then it will say so. It'll say that it's a tapered hole. Just like how if you just do a normal one, it would specify that it's like a tap, I believe. Or I think on here, yeah, it'll say it's a tapped hole as opposed to that sucks. Both of them do say that they're tapped holes. You just need to be a little bit cognizant as to how it's tapped. So if it looks uniform straight through, but only part of it is threaded, that this kind of look to it, then it's a straight tap. If it has this little lip here that separates the threaded portion to just the regular portion of it, then it's a tapered tap. Hopefully that was a bit more of a cogent answer.